Hello, everyone. In this lesson, we will learn about the timer instructions, types, parameter description, timing diagram, etc.
Through this lesson, we will achieve the following learning objectives. 1. Identify the 4 types of timer instructions. 2. Explain the principles and differences among these 4 timers. 3. Use timer instructions to write time control programs for motors and indicators, and perform online debugging. First, let's review the 4 types of timer instructions available. The S7-1200 PLC offers 4 types of timer instructions: pulse timer, TP, on-delay timer, TON, off-delay timer, TOF, and accumulating on-delay timer, TONR, also known as the retentive on-delay timer. These timer instructions can be represented using function blocks or coils, as shown in the diagrams below. Next, we will focus on understanding the meanings of the various parameters in the functional block diagram of the timer instruction. The meanings of the various parameters in the timer instruction block diagram are shown in the table below. IN is the timer enable input. When the IN terminal is activated, set to 1, the timer starts and begins counting. Q is the timer output bit, which turns on or off when the timer current value reaches the preset value. PT is the timer preset value, representing the desired delay time we set. ET is the elapsed time since the timer started, referred to as the current time value of the timer. R is the timer reset terminal, unique to the retentive timer type. DB is the background data block of the timer, and its data type is IEC_timer. The timer background data block is shown in the figure. In the system block, program resources, it includes the timer preset value, PT, the timer current value, ET, the timer input bit, IN, and the timer output bit, Q. Before programming with timer instructions, we need to create a data block of type IEC_timer, since the system does not provide a preset background data block for timer coil instructions. We can name the data block as default or custom, for example, T0, T1, otherwise, programming will not be possible. Next, we will learn about the specific details of the 4 types of timer instructions. 1. Pulse timer, TP. The pulse timer instruction generates a signal output of a preset length. The ladder diagram and timing diagram are shown below. From the timing diagram, we can see that when the IN terminal receives a rising edge, the timer will generate a 20s pulse and output it through the Q terminal. During the pulse output period, if there is another rising edge or if the IN terminal disconnects, it does not affect the generated pulse width. During the pulse output period, if an external signal activates the timer reset coil, the pulse width output will stop. However, if there is a signal at the IN terminal while the timer reset coil is also activated, the timer reset coil will not take effect. 2. On-delay timer, TON. The on-delay timer instruction delays the output signal by a preset time length. The ladder diagram and timing diagram are shown below. From the timing diagram, we can see that when the IN terminal signal is set to 1, the timer begins counting. When the elapsed time reaches the preset value PT, the Q terminal output becomes 1. During the timing process, the IN terminal signal must remain active, otherwise, the current timer value will reset to 0. Once the timer's elapsed time is complete, the current value ET stops counting. If the IN terminal signal is then set to 0, the current value will immediately reset to 0, and the timer Q output will change to 0. 3. Off-delay timer, TOF. The off-delay timer instruction delays the reset operation of the output Q by a preset time length. The ladder diagram and timing diagram are shown below. From the timing diagram, we see that when the IN terminal is set to 1, the timer Q output immediately becomes 1. When the IN signal disconnects, changing from 1 to 0, the timer starts counting, and when the current timer value ET equals the preset time PT, the timer Q output changes to 0. If the timer is actively counting and the IN terminal is set to 1 again, the current value ET resets to 0. The timer can also be reset using the timer reset coil, which will clear the current value. It is important to note that if the IN terminal input signal is in the 1 state while the timer reset coil is also active, the timer will not be reset. 4. Accumulating on-delay timer, TONR. The accumulating on-delay timer, or retentive on-delay timer, accumulates the time until the preset value is reached and then outputs a signal. The ladder diagram and timing diagram are shown below. From the timing diagram, we can see that when there is a signal input at the IN terminal, the timer begins counting. When the IN terminal signal disconnects, the timer stops counting and retains the current elapsed time. If there is a signal input at the IN terminal again, the timer will continue counting. When the timer current value, ET, accumulates to the preset value, PT, the Q terminal output will become 1. At this point, if the IN terminal signal disconnects, the timer will retain the current value, and the Q terminal will remain in the 1 state. If the reset input has a signal, the timer resets, or we can reset the timer using the reset coil. Otherwise, the timer maintains its output state. Among these 4 timer instructions, the on-delay timer, TON, is the most widely used. So, how do we apply it in practical programming? Let's work on an exercise. We have 2 motors, M1 and M2. When the start button is pressed, M1 starts immediately, and M2 starts after a 4-second delay. When the stop button is pressed, both M1 and M2 stop immediately. The ladder diagram is as follows. The design concept is as follows. Pressing the start button I0.0 energizes coil Q0.0, starting motor M1. The timer starts, and after a delay of 4 seconds, coil Q0.1 is energized, starting motor M2. Pressing the stop button I0.1 or an overload condition will stop both motors M1 and M2 immediately. Let's monitor the PLC operation to verify if our programming approach is correct. When the start button I0.0 is pressed, starting motor M1, and the timer starts. When the timer reaches the preset value of 4 seconds, the timer output Q is activated, starting motor M2. Pressing the stop button I0.1, stopping both motors. In this lesson, we provided a detailed introduction to the functions and applications of the 4 types of timers in the S7-1200 PLC. We also reinforced the application of the on-delay timer, TON, instruction through practical exercises. That concludes this lesson. See you next time.